We're gonna get started in just a moment, everyone. Wait for everyone to get in. Okay, welcome to Politics and Prose Live. We are here today with Sarah Stewart Johnson and Alan Lightman. And before we get started, I just have a few quick housekeeping notes. The first is we really encourage everyone to purchase today's book, The Sirens of Mars. I've put a link in the chat to Politics and Prose's website where you can purchase the book. It's a great way to support our author and also a great way to support Politics and Prose. Secondly, the final portion of the event is going to be dedicated to your questions. We have an Q&A button at the bottom of your screen. If you hover your mouse over it, you can see that. So that's a great place to put your questions, and we're going to try to get to as many of those as we can. And with that out of the way, it is my honor to introduce Sarah Stewart Johnson. She is an assistant professor of planetary science at Georgetown University. She is a former Rhodes Scholar and White House Fellow, and she received her PhD from MIT. She's also worked on NASA's Spirit, Opportunity, and Curiosity rovers. She is also a visiting scientist with the Planetary Environments Lab at NASA's Goddard Flight Center. This afternoon, she'll be discussing her new book, The Sirens of Mars, which tells the story of how she and other researchers have scoured Mars for signs of life, transforming the planet from a distant point of light into a world of its own. Joining Sarah in conversation is Alan Lightman, a former theoretical physicist and the author of 6 novels, including the international bestseller, Einstein's Dreams. So without any further ado, here are Sarah and Alan.
Well, thank you, Tom. And it's my pleasure and honor to be joining Sarah for her wonderful new book. I first met Sarah at MIT, and I think a little bit later, you invited me to a dinner at the Junior Society of Fellows at Harvard, or the Harvard Junior Society. Am I remembering that right?
Yeah, you did come to one of those dinners.
Yes, so it's a very prestigious fellowship for people at Harvard who have a wide range of interests, and that certainly describes Sarah. And I think you were already thinking about writing a popular book about Mars at that time, which was many years ago. I can't remember exactly when it was. And I was very impressed by you, not only because that you were an outstanding young scientist, but also that you were a superb writer. And that's very rare among scientists to have both the ability in science and the ability in writing. So I'd like to start by asking you that you tell some wonderful stories in your book about how in childhood you got interested in astronomy. And I wonder whether you could tell a story or two about that.
Oh, that's a great question to kick off. So I grew up in Kentucky, and I did have these things sort of pervasive in my childhood, I'd say. My father really liked astronomy. He subscribed to astronomy magazine, and he could get some binoculars and look up at this night sky from our backyard. And he also liked geology quite a lot as well. So we'd go on these trips, and my sister and I would be in the backseat of the car, and there'd be these funny moments when he would wait, and he would I just always hated the smell of coffee as a child, and so did my sister. And we would be driving along, and he'd open up his thermos, and we would just roll in the backseat saying, "Oh, I can't stand that smell." And sometimes you'd take that as an opportunity to pull over to the side of a road and look at these road cuts, investigate the geology. There's wonderful geology here in this state. And I think at the time, a lot of that was just like, "Oh, Dad," just like, this is so embarrassing. Like, if my middle school friends had been around, I'd been so embarrassed. But it was really quite funny, because then I got off to college. I went to college at 18, just over to Missouri, the Washington University in St. Louis, and And I just found like all these things were gravitating back to me. I mean, these were the things I was drawn to, these fields, these subjects, these ideas. And it's just funny sometimes how things come full circle like that.
Do you have any memories as a child of sort of looking up at the night sky and wondering about it?
Yeah, for sure. It's interesting. So in Kentucky, we don't quite have the night sky views, even in very dark areas, as they do say out west, or really far away from light. We've got a pretty humid atmosphere here. And so seeing the stars, there were these times when it just seemed like, what is that? You could kind of imagine the sky not being so much, this way, but more like this. And like, could there just be this dome that's inverted? And what are these pinpricks of light? And where did this all sort of come from? And it's been kind of fun to relive some of that wonder now with these little kids I have, because I see them, asking the same sorts of questions, looking up and trying to make sense of, what is that? And why does it look like that? And why does it look different here than it does other places? And I had some opportunities to go down to the Southern Hemisphere, which has been really fun. But it's, yeah, I think so. I mean, there is one moment that I wrote about in the book, that the idea of sort of the night sky connected with me in a way that it hadn't before. Was the trip that my dad did with me out to Arizona. And I was in college at the time, in my probably very early 20s. And we were staying at this place which had beautiful night skies, kind of high up, very still air. And there were these medium range telescopes. And I had never had the opportunity to look through a medium range telescope before. And so like I'd always seen kind of the naked eye with binoculars or maybe a small little telescope. And I had also at this point, like I'd done some college internships. I'd been to some NASA places and some observatories where there were these giant telescopes, but they were, sort of distant in a way. Like all the images came up on screens, and
Right.
they didn't feel like you had a direct relationship with the night sky. And just on this trip that my dad and I took, I mean, there were these incredible telescopes, and we just, we'd look and you can just see this dot, like, oh, it's that one. I mean, those are actual polar caps on that dot, or those are tiny moons just all around that other dot. And I think that was a moment that it really sort of connected with me and allowed me to kind of understand like how the planets appeared to these kind of early astronomers that just had these, telescopes as they began getting better and better.
Well, there is a big difference between looking out of a telescope, a medium range telescope, as you say, or a small telescope, and one of the large professional telescopes, where, as you say, professional astronomers don't even look out of a telescope anymore. They look at a computer screen, and it's very detached and remote. And although there may be that may be a more accurate way to collect data, it sort of eliminates that beautiful visceral experience of looking out at the sky yourself, either with the naked eye or through a small or medium range telescopes. I remember the first time that I saw the rings of Saturn and a medium range telescope, it just blew me away, because the rings of Saturn look so perfect. It doesn't look like anything that could be it doesn't look like it could be actually real or natural. It's so perfect. But of course, a snowflake is perfect as well. So,
Yeah,
but
sure.
So you got interested in astronomy at a young age, partly with travels with your father. But there are a lot of things that an astronomer can study. I mean, there's lots of things up there. So why did you decide to study Mars?
Oh, that's a great question as well. So I just stumbled into some really tremendous opportunities in my 20s. And actually, before that, the very first one I'd say was when I was 18 years old. I was a freshman in college, and I arrived, and there was this professor who was a Mars scientist, and his name is Ray Arvidsson. He was at Washington University, and he let me start working in his laboratory. I was taking a class with him, and I started working in his planetary science laboratory, and he was a Mars scientist. And it was incredible. So that first year, we took a trip out to the Mojave Desert in California, and we were there testing these prototype rovers, the precursors to the rovers Spirit and Opportunity that would go up to Mars and land in early 2004. And oh, it was magical. The whole thing was just magical. And as part of that trip, I also got to go with him to NASA's Jet Propulsion Laboratory, which is in this canyon north of Pasadena, as I'm sure you know.
Right.
And it's kind of the epicenter of robotic exploration for NASA. And, you know, just seeing all of these plans coming together and these brilliant scientists and these engineers and just kind of thinking about kind of planetary targets. And Mars just seems so incredibly exciting, and we have these opportunities to go to Mars so often. Every 26 months the planets align on the same side of the sun, and starting, you know, from the late 90s, we've been taking advantage of all those opportunities. And it was just this kind of renaissance of Mars science that was coinciding with me arriving at university and then getting ready to go to graduate school. And so I guess that's the main way I found my way into it.
So was there a renaissance in Mars science because Mars was accessible by exploration? Rocket exploration, is that the reason? Or telescopically, that it was, suppose that your professor at WashU had been interested in Venus or in Jupiter. Would you have become interested in those planets rather than Mars?
Well, I have to say those rovers were pretty alluring, and we haven't been able to send rovers to those other planets yet. So we didn't have a good reason for not going to Mars before the late 90s. So we started with our very first flyby mission in 1965, and we continued to send more missions in the late 60s, and in the 70s, we landed 2 probes on the surface of Mars. And those missions, Viking 1 and 2, had these miniature life detection experiments on them. And those results came back. It was very confusing when those first results came. You know, there was this huge response at first to one of the experiments, and, you know, some members on the team were sending out for champagne and cigars, but then the signal disappeared, and there were controls that should have been negative that came back positive. And the results really, you know, were that we couldn't find any of the building blocks for life from using another chemistry instrument. And the community took away that this huge experiment, kind of the greatest experiment in the history of science as it had been built, had just come up dry. And following the Viking mission, we had 20 years where we had no Mars missions. And I think it must have been a tremendous disappointment to the graduate students and the postdocs who had trained up in that previous era. There's several reasons for that. You know, in part, there were other targets in the solar system. In part, I think it was a bit of this disappointment that the surface of Mars just seemed bleak and maybe devoid of life, which had been, you know, really exciting leading up to the Viking mission. But I think there was also bad luck, because there was a mission that tried to make it up to Mars in the early 90s, a big NASA mission that lost communication 3 days before it arrived at the planet. But we had this period for 20 years where there was just nothing, really. There's just nothing, you know, besides some telescopic observations. But then in 1997, there was a new NASA administrator, and there was this idea of missions that were better, faster, and cheaper, and we'd send a lot of them, and they'd be smaller, and we'd go at every opportunity. And we sent the Pathfinder rover, we sent the Mars Global Surveyor, and we just kept sending missions and missions and lots of missions. And so that's what I'm talking about with the renaissance of Mars exploration, is that from that period, you know, the last 20 years, more than that now, we've just been going back and going back and going back again, which has been, you know, and the planet in that time has really burst into technicolor focus with all of the scientific returns that we've made.
Well, during this period, why did we not send rovers to Mercury and Venus? I can understand you wouldn't send it to Jupiter since it doesn't have a solid surface and it's further away. But why not send a rover to Mercury and Venus? in your opinion?
Well, so there were, I think that it's been really sad. We've barely explored Venus. We haven't had a Venus mission in an extremely long time. Mercury's very hot, of course, much closer to Earth than the outer planets. We've been trying actually to land probes on surfaces of these icy moons, these kind of ocean worlds that are out floating in the distant parts of the solar system, orbiting Jupiter and Saturn and Neptune. But, there are lots and lots of challenges. We've only sent 4 rovers to Mars. We had little Pathfinder that was the size of a suitcase that really was just a technological demonstration, followed by the 3 rovers that have just returned so much science, the Spirit and Opportunity and Curiosity rovers. And then, of course, Perseverance, the next big one that's going to launch later this month.
Do you think that, I want to ask you about your own research in a minute, but do you think that the possibility of finding life on Mars, which of course has been something discussed for centuries, and an issue that's very central to your book, do you think that may have been one of the reasons why we have concentrated more on Mars than on Mercury and Venus, say, which are also close by, relatively close by?
Yes. And I'm sorry I sort of didn't make that clear earlier. I think that's got to be one of the biggest driving reasons. It's not the only place in the solar system that we think that would make a good astrobiology target, but it's definitely the closest one. And we've done the hard work of getting to know the place, and we've developed incredibly sophisticated tools and technologies, and we can land just so much scientific equipment on the surface. Curiosity rover, that's a metric ton. That's a mobile science laboratory that's roving around in Gale Crater there. And there are some really good reasons to think that life could have gotten started on Mars. The planets had different paths, but early in their histories, around the time life was getting started here, Mars was much, much more like the Earth. And in fact, it's the closest planet we've ever found to the Earth in terms of composition and environmental conditions. And, we've shown, the Curiosity rover has proven that all of the sort of fundamental ingredients we need for life as we know it were present on the planet's surface, that a long time ago it was awash in water, and that water might not have been there all the time, but at least episodically the conditions were warm and wet, and you could have a solvent, you could have all kinds of chemical mixing. And we've finally found those organic building blocks that the Viking mission struggled to find, and we kind of understand that there are things about the Martian soil that make them hard to detect, but they're there, those carbon containing molecules that that are the building blocks of life as we know it as well. So I think that, we look at Mars and we know here's a place that has the conditions that are so similar to where life got started here. And so it's just, not only is it near and accessible and easy to go to and do great science, but it's got, so much going for it in terms of, its own planetary path.
Well, I want to come back to that, to the significance of finding life on Mars, and that sort of is a driving force of our imagination, which is very prevalent in your wonderful book. But let me go back first to your own particular research, and I'm sorry to tell our audience that you haven't personally been to Mars, as far as I know, but I know that you've done a decade of research on Mars. And I imagine that some of that is laboratory work and field work on Earth. So tell us about some of the most interesting work that you yourself do in your team here on Earth.
Oh, that's a great question, Alan. And I should say it's very much a team. So I run a laboratory at Georgetown University, but I've got 12 folks that are working in there right now. And so we all do these things together. Couldn't do any of them alone. But we run, so it's a biosignatures lab. So the idea is to look for traces of life. And we use a couple different techniques. We draw from organic geochemistry and molecular biology. We've got lots of instruments in the lab, big clean room. And so one thing that we do is we kind of think about developing tools and techniques and technologies. And then we also try to test them out in analog environments, places here on Earth that bear relevant similarities to places on Mars and other planetary targets, places that may have similar mineralogy, where we know there's once life in, say, some ancient lakes, but those lakes have dried up, just like the lakes have dried up on Mars now. So we can go to Antarctica, for instance, and we can look in these ancient lakes and we can figure out the best ways to pull molecular fossils out of those sediments. Like, that's an example of the kind of thing that we do. And it's been fun because we get to go off to the ends of the earth. I remember on my very first date with my husband, I was telling him about some of my research, and he said, I'm not sure I would have gone into law if I had known that you could go to like all 7 continents as a planetary scientist, but you can, and it's been really exciting. And then like another part of what we do is we kind of look at data coming back from spacecraft and think about instruments and different approaches that we can use for future missions.
So that some of what you described sounds to me like biochemistry. And so it's kind of interesting that a person who would be called an astronomer is really has to have expertise in biochemistry. Did you study that at university?
Yeah, well, so planetary science, looking specifically at planets, like especially, just in general, it draws from a ton of fields, right? You've got to understand geology and physics and chemistry. And then astrobiology really brings in the biology as well. And it kind of sits at the nexus of all of these different scientific disciplines. And so in my path, I started off kind of studying mathematics and environmental science, and I was doing planetary research as an undergraduate. And then I had a chance to get a master's degree in biology and a PhD in planetary science. And I even had a short little diversion in there where I spent a couple of years studying philosophy, politics, and economics, which has been surprisingly useful. I think that these huge missions that NASA and other space agencies send, they inherently have these political and economic dimensions, and the philosophy I just loved, kind of thinking about these big existential questions. But yeah, I just love lots of different, I was in school for a long time. I really enjoyed school.
Well, okay, you mentioned philosophy, so I'm going to ask you a philosophical question. Did you study that at Oxford, the philosophy?
I did, yes.
Okay, yeah, good place to study philosophy. So, I know that a lot of your work and a lot of your book is about the search for life on Mars. It's not just about the planet of Mars and the physical characteristics of Mars, but it's specifically aimed towards looking for signs of life. And so why do you think it's important to us as a species, Homo sapiens, to search for life elsewhere in the universe? And what is it for you that is important about that?
That I feel like is the driving question behind why I wrote this book in the first place, Alan, just this trying to understand like why this was so important to me and why I found such meaning in it, and this idea of wrestling with these questions, like, are we alone? And why are we here? And why is there something and not nothing? And why was like, and could that something from nothing, could that have happened once, or did that happen time and again? And it's one of these questions that I feel really restless about. And I think that's why I love doing astrobiology, because it feels like I was so lucky to be born into this time and place where we have a space programs that can actually access these extraordinary destinations, and that we are, potentially within reach of an answer, even if it's small and simple life. I talk about this a lot in the book, just like kind of just the smallest breath and the deepest night. We could learn so much from even the discovery of a tiny, tiny microbe. It doesn't need to be an intelligent civilization. I mean, biology in many ways is a kind of descriptive science, and we're limited by the fact that we have this one data point. Like all the biology we know of is the same. It's the same DNA-based, carbon-based stuff that makes up our own bodies and everything else that's alive here on our planet. And just to have a second data point would be extraordinary. And there's a possibility that Mars and Earth, because they're so close to one another and they exchange so many rocks, especially early in their histories, that we could have just caught life from the next planet over. But even that, I think, would be just amazing to study some evolutionarily separated life. I mean, it'd be like playing the tape of evolution over again and running that great experiment and seeing what turned out. But the thing that really excites me the most is this idea of a separate genesis, a type of life that's completely different from anything we've ever conceived of. And I just think it would bring so many kind of foundational and constitutional pieces of knowledge. Maybe life is just a consequence of energetic systems. Maybe it's kind of an emergent property that's part of planetary evolution. Like I just think there's so much that we could learn. It'd be better than anything some pharmaceutical company could come up with, just figuring out if there's another point, like if we're just not alone in this vast dark night. I just find it incredibly compelling to think about that kind of thing.
Of course, part of this discussion depends on what is your definition of life. And you said that we're not necessarily talking about intelligent life or life that has consciousness or life that has 100 billion neurons, but something very primitive. And I think biologists have a list of criteria of what constitutes a living being, but it's somewhat arbitrary. The list of the ability to metabolize, to separate from your environment, et cetera. So I think that's one interesting question that's brought up. But let's not get into that question right now. I know that a satellite that was launched a few years ago called the Kepler satellite has been looking for habitable planets, or planets that are the right distance from their central star to have liquid water. And I guess most biologists believe that liquid water is probably necessary for life, even if it's life very different from Mars. And Kepler, I think, has found that about 10% of stars have planets that are in the habitable zone, which is a pretty large fraction. But we still haven't found life elsewhere. Even on Mars, we haven't found definitive evidence for life. So this next question is going to be, I want to ask you a couple of questions about this, pretty far out. But suppose that we did not find life anywhere in the solar system, and as you say, a biosignature, indirect evidence of life, however the biologists define it. And suppose that we do not find, let's say in the next 30 years, I mean, you're much younger than I am, but let's say for your lifetime, next 50 years, we don't find a biosignature in all the planets that we're looking for outside of our solar system. And what would we make of the possibility that life is unique to Earth? I mean, you said that that you have a passion for finding out what's out there and what are different evolutionary tracks and so on. But suppose that we concluded, I think this is unlikely, but suppose we did conclude that life were unique on Earth. What would that mean? I know this is a very hard question and you don't have to answer it. And because the next question I'm going to ask you is what would it mean if we do find life elsewhere? But I'll start with that one. Suppose that and you could just say, well, we would never be able to conclude that.
Well, I do think that's right. I mean, I do feel like we will never really stop searching, even if we're searching farther and farther out into the deep night. I think that one thing that has really come from the exploration, even just of our near neighborhood, our own solar system, is, just how incredibly precious this planet is and how extraordinary and tremendous and just this existence of ours. It's so poignant. I wrestle with this a lot in the book, like we're just this small species. And when you think on these enormous distances and you think in terms of geologic time, it's like we have this moment, this just tiny moment, each of us, to live out our lives. And it's just so very important that we make the most of it. And I do feel like kind of that perspective that comes from planetary science is really important, whether or not we're sort of fruitful in this search. Part of me is so optimistic because I feel like we haven't even scratched the surface yet, like we're still kind of doing the fundamental work of understanding these other worlds. For instance, on Mars, we haven't found life, but we also now know that the surface is this incredibly hostile place, bathed in this high energy solar and cosmic radiation. And if there is life, there's a much better chance, I think, at least, that it would be in this simple form down in the subsurface. You don't even have to go that deep in the subsurface to get away from that really punishing surface environment. But, we haven't done that. We haven't looked there yet. And, more than half our biomass here on our planet is in the subsurface in microbial form. And I would think that'd be the greatest place to retreat from, this world where the magnetic field goes away and there's very little atmosphere. But I do think that there are just lots of possibilities. I think when I think about exoplanets, they may seem just incredibly distant, these aberrations of light that are, how could we know much more about them than, maybe a little bit about the composition of their atmospheres, maybe. But the idea of visiting one just seems impossible, like just science fiction, right? Because they're light years away and the universe has a speed limit and it's slow. But I also think that that's how Mars seemed a century ago, like just completely inaccessible. The idea of going there with these kind of extraordinary robots was science fiction. And that's just one human lifetime that we've gone to actually. And so maybe there are these tiny little gram-sized spacecraft that we're going to be able to send far, far away, propelled by lasers or some amazing technology. Like I think it's going to be really incredible to watch in the decades to come.
When do you think that the first humans will land on Mars?
Oh, that's a great question. So I think the stage is set for rapid progress there if we decide to do it. So I think that the leap from kind of what we had before Sputnik, when there was nothing, and going to having people on the moon, that was 12 years. Of course, it was a huge effort, it was comparable to wartime spending for the United States to do that and to achieve that goal. But I think that the technological leap, while serious, and I'm not downplaying it, there are just lots of things that we have to work out in terms of, physiology and propulsion and survival. But I think that leap is a smaller one than the one we've already made. Mm-hmm. And I think it's going to be really interesting sort of seeing what happens. There are a lot of things disrupting kind of traditional space exploration. There are new players, the Chinese Space Agency is coming on strong. They're launching an orbiter, a rover, and a landing platform up to Mars later this month. And there could be, say, another space race that kicks off. You've also got, private companies coming in. SpaceX says they want to send a million people on 1,000 spaceships up to Mars. I'd love to see it as an international endeavor led by the science, of course, but I don't know. It's been one of these things that seems like it's sort of like cold fusion. It's always been 30 years away when people talk about it. And I just think it's going to really depend on sort of world events, and again, those kind of political and economic forces coming together.
Well, you mentioned that the Chinese effort, a new space race might actually accelerate the landing of humans on Mars, because that was really what accelerated the landing of on to the moon, and the moon in the late 60s was the competition with the Russians, and it may be that would have a positive effect. Let me change gears a little bit. In just a few minutes, I'm going to open up for questions from our audience, and I can see there are already a couple of questions. But let me take a step back. When I started writing about science for the general public in the early 1980s, it was still very a taboo for scientists, practicing professional scientists like yourself, to take some of your precious research time and use it instead to write books for the public. And there are more scientists who write books for the public now, but still it's a small minority of practicing scientists who write books for the public. So why did you decide in your case to give up some of your research time to write a book for the general public?
Well, there really hasn't been a lot of time when I mean, so some folks that are watching probably know that I've been pre-tenure the last 5 years, and I've also had these small children. And so most of this book, I think, got written in these little pockets of time, like just in the middle of the night or on the weekends, or I think that's why it took me so long because I was doing research, and that was my biggest priority, over the last few years. And I think you're right, like this idea, it's almost like I wasn't writing this book for so long. I spent so much time kind of percolating with some of these ideas that I wanted to include in it. And then I finally just started scribbling it down, and it sort of slowly came together. I wasn't sort of playing tennis or golf or gardening. I feel like I have no other hobbies. There's a lot of cereal for dinner in the last 5 years. But one thing I really do think that has come out of this is I think that I am a better scientist for having written this. And I think about, just being in the lab and tinkering around with things and ideas. And I've always been trying to sort of connect them up to these kind of bigger questions and these kind of bigger processes. And I think that, you kind of see that, I think, sometimes in the book and in my research as well. Like, I guess one example is one of the projects that I'm most excited about in the lab right now is this grant that we've gotten from NASA for $7 million to search for agnostic biosignatures, which are traces of life that don't presuppose like a specific underlying biochemistry or a particular molecular framework. It's kind of searching for life as we don't know it, as opposed to kind of life as we do know it. And it's been so fun to think about that. Like, it's almost like imagining some color that you've never seen. And
you still have to have criteria for what constitutes life, right?
Yeah, well, that was so interesting because you brought that up earlier, and of course there are. We get together as astrobiologists. These are kind of like our drinking games. We think about what is life, how do we define it, and there are even people in the field that say it's premature to define it. It's like you couldn't really define water before we knew about chemistry and before we knew that hydrogen and oxygen atoms came together to form that substance. You could just kind of describe it or say, oh, I know it when I see it, but we didn't really. There are folks that think that we're just like too early to like really understand life because we just have this one form of life. But, in this project, for example, like we're looking for things that are really distinct from random processes. So things like unexplained chemical complexity or accumulations of elements or isotopes or evidence of energy transfer. These are the kinds of signatures that we're looking for, where we could say, maybe not definitively the way we could if we found a DNA sequence or a Hopane, you know, but like this is say 3 sigma away from what we'd expect from abiotic processes. I've got a colleague on the big grant team, and he likes to say, if you found a 747 on the surface of Mars, you might not know how it got there, but you'd know it wasn't random, you know? But I think that like there are like so many parallels between even just that research project and this book, because I mean, if you read the book, I mean, throughout this theme of, you know, we keep on kind of expecting to see ourselves, you know, my predecessors, all these planetary scientists that came before me, we kept on getting surprised and astonished by the fact that Mars wasn't Earth. You know, we look at it and it's the nearest thing to Earth we know of, but at the same time, it's just indescribably foreign, you know, and to work on Mars is to contend with a truly alien, and you have to be able to do that. And it's not just the physical environment, it also potentially could be the types of life there.
Yes, well, I would think that simply finding unusual complex chemical processes would not be enough to convince me that that was a living organism. I mean, we know Mars is very different from us. It's gone through a different history. It may have different chemistry. But anyway,
well, Alan, you don't have to worry about that, because NASA lets us send packages of packages of instruments. We usually get to send like 6 or 7 per mission. So we don't have just one observation. We could potentially have many lines of observation.
Yes.
And which will also make you happy, we're starting right in a couple of weeks on this breathtakingly ambitious campaign of bringing samples from Mars back to Earth, and that we can study in our laboratories. And so we don't have to do everything in situ. But go ahead. I feel like I cut you off.
That's fantastic. Well, we have some questions here, and I think there are a lot of questions. D. Levinsky asked whether Mars is your favorite planet.
Oh, I suspect that's my brother-in-law. So yes, Mars is my favorite planet. That's probably obvious. But it's been funny. Like, I've been trying to get my kids excited about Mars, and they always tell me that no, Mama, no. They like Jupiter and they like Saturn.
There's a political question here. From Richard Lazarus, which I think is very funny, but I'm not going to ask it to you, but I congratulate Richard Lazarus. There's an anonymous attendee who says that acknowledging that we have to start with what we have, what we know, would we necessarily recognize a second data plane distinct from what we know?
Like a second form of life, and that's
maybe a second form of life. Yeah. So you said something about that earlier, but how would you recognize it if it was a form of life? You know, whatever criteria the biologists come up with what constitutes life, if you found something that was incredibly different from anything we know on Earth, how would you recognize it as life?
Yeah, no, it's a really great question. And, you know, I've gotten to be part of some really exciting workshops done from like the Library of Congress and the astrobiology program, you know, thinking about things that are just way out there, you know, like biology that's not even tied to chemistry any longer, you know, kind of a post-biochemical type of life. And I think there are a lot of things that we might miss, right? But I think if we're sort of still in the realm of kind of biochemistry and sort of physical things that we could pick up, I mean, it is really important, even the time scales over which we're looking. There's a story that I write about in the book, Voltaire's micromegas from the 1700s where this giant comes to Earth and just thinks it's devoid of life because he's 120,000 feet tall and he can't see anything. And then there's this little piece of flotsam like down, and he plucks it out of the Baltic Sea, and he realizes it's a ship full of sailors, and he listens to their tiny little voices. And and I think it's like a really interesting allegory, thinking about like what could we be getting wrong? Like, would we have the scale of life entirely wrong? Would we have the time scale wrong? Like, could we even recognize it, if it just hit us out of, like, if it was just right there.
Yeah.
And so I think that there are lots of things that we could potentially miss, of course. And, just
Well, I think basic physics and biology tell us a little bit. You can't have something that's 100 miles tall because it wouldn't be able to, it wouldn't have enough tensile strength to survive a fall. So there's some things that are not scalable. We wouldn't expect to have intelligent life unless it had a minimum number of neurons or something equivalent to neurons. I remember that Fred Hoyle, the British astronomer, wrote a science fiction book. I think it was called The Black Cloud, in which his hypothetical life form was just a big cloud that stored information electrostatically and sort of communicated with itself completely by electricity. But anyway, it's fun to think about possibilities. I'm going to go to some other questions because we've got a bunch of them. This is from an anonymous attendee who says that you, Sarah Stewart Johnson, are in a unique position to message to people that Earth is precious, which is something you said earlier. How can regular people convince those holding the reins that apathy and inaction are not the best way forward to save humanity and the remaining life on the planet?
Oh, I spent some time working on sort of climate policy for a while, so this really resonates. Like we have this just incredibly precious world. I think about the time that humans arrived on the scene. We had 100,000 different species of orchids that had already evolved on our planet's surface, and we kind of, I don't know. I mean, we've broken a lot of things since we've been here, as we've exploded and covered the face of the Earth, and it's really been hard to sort of see kind of how unsustainably we've been living, and how important it is to come together. And it's just, I feel like it's a hard moment because there's so many like very hard things in the world, and there so many things like with the environment, but just beyond that are just not going the way many of us would have hoped that they would be at this point in time in 2020. But I think that so I got to spend a couple of years working in the White House and the science office there, but I think this applies much broader than the science office. Is like there are a small number of people making a very large number of decisions. Like, for instance, I was like 29 years old. Like, I should not have had the responsibility that I had, but there are other 29-year-olds that have a lot of responsibility for how things get made. And I think being involved in the political process is just so critical because, these few pressure points, like if you reach the right people, or you kind of reach out to like the important folks in Congress that are sitting on these important committees that are seeing these important decisions, it could just be, a little bit of constituent pressure that pushes like a domino, and everything falls from that. And I just think it's so critical that people vote, and that people, are politically active and are thinking about these sorts of things, and also on a personal level, you think about sort of what you're doing and the impact you're having on the environment and the world, and how you can change things. I think that's also just incredibly important. But I don't know. I mean, climate's been one of the hardest issues, right? Because it's like this thing that is happening, but it's happening sort of the worst part of it's in the future. And again, it's like, it's so hard for us to conceptualize like what that's going to be. And we have to act before that happens. And it's just so hard when there are so many immediate things around us.
Mm.
I mean, it's almost like you can go to a war-torn country and you can be walking around and the sun is shining and you just think, oh, this is fine. This is pleasant. Look at these birds singing in the tree. And it's so hard to like connect with realities about those types of things.
Especially things that are in the future. We don't do very well with things that are going to happen too far in the future. I mean, people in California keep building their houses on the San Andreas Fault. In Mount Vesuvius, people built their houses on the side of the mountain because they thought it was far from the future. You can't tell a 20-year-old not to smoke cigarettes because it'll cut 5 years off their life when they're age 80. We don't do well with things that are further than a few months away. I have a question from Christopher, who is age 5, and I hope that Christopher is listening to this.
Christopher.
Do you know who this is?
I don't actually.
I think that maybe his mother is Alexandra Givens, but.
Oh, I do know this Christopher. Hello, Christopher.
Well, Christopher asked you, what is your favorite cool fact about space?
Oh my goodness, so many good facts. All right, how about this, Christopher? If you were standing on the surface of Mars and it was the evening, you might look out and you would see the sun setting, just as you see the sun setting here on Earth. But on Earth, you might notice that the sky turns pink and orange, and it gets really beautiful when we see these sunsets. And the sunsets on Mars are just as beautiful, but instead of turning red and orange, the sunsets are blue on Mars. And it's just baffling. It's this completely incandescent color that just kind of rips at the seams of what you imagine a sunset to be. But if you looked out, you could see the setting sun and this beautiful blue halo of color around it.
That's great. It must have something to do with the atmosphere or lack of.
Oh, indeed. And Christopher, as you get older, we will talk about Rayleigh scattering and my scattering, right. And we'll understand all the microphysics of the system, yes, and the properties of light. You can
Christopher will learn about all that in a few years. So here's a question from Rohana Gubin. You're married to a wonderful lawyer. How can lawyers advance the cause of space exploration and the search for life?
Well, the wonderful lawyer that I'm married to has been doing a really great job helping planetary science. He has been learning all about the planets over the last decade or more that we've been together. I don't know. I mean, so actually space policy and space law, Rohana, if you're looking for a new career, is a Wild West, a total Wild West. We have these instruments of policy that were created in the 1960s, like the Outer Space Treaty, that are just completely outdated, that just, did not ever anticipate a whole host of things like private companies, the idea that, you could just launch, maybe if you don't want to launch within the United States and have the rules of the United States, just go to Luxembourg, you find your flag of convenience. There were so many things with like space junk. What do you do about that? All of these issues that are coming up now about jurisdictions and territories and rights to, say, companies that want to mine the moon. It is a Wild West, and we need people that know about the law that could come in and like sort of help get this whole thing under control.
Here's a question from Mac. Hi, Sarah. Can you talk about your work in South America at these lakes or near drying lakes? And how it relates to the Martian soil.
Oh, okay. Yeah, well, I wonder if it's a question about some of that Antarctic work that I was talking about earlier. So those are even further south than South America, though I've also done some work in the Atacama in South America. But the lakes that I was talking about earlier are, so the dry valleys of Antarctica are just one of the driest deserts on Earth. There's been no rain in 2 million years. You touch down, it's like you're on another planet, and in Antarctica, and you helicopter down into them. And these lakes used to be much, much higher. They used to go all, high up on the valley walls. And that was millions of years ago. And slowly they've receded to the point where there's just an ice-covered lens of fluid sort of at the bottom. And so the project that we got funded by the National Science Foundation to do over the last few years has been to look at how life that was once living in these lakes, this microbial life, which is still present in these smaller ice-covered lakes there at the bottom, is preserved over time. And so the thing about Antarctica is there are no plants, like no land plants, no animals. Like it's a place where microbes really rule this biological scene. And this is very interesting, I think, as an analog for Mars, because we also know that there were lots of lakes on Mars that have also evaporated and have come into this very arid environment. And so we've been able to go and using like different types of technologies, looking for traces of life and even evidence in some cases of cells that are still eking out an existence in these paleo shorelines that have been left behind and just kind of freeze dried into the Antarctic environment. So there's lots to learn about these lakes if you're interested, both from an astrobiology perspective, but also kind of from a global climate change. There's a long-term ecological research project that is set up down there that's funded by the NSF, where scientists go year after year to look at these lakes. And I think this is actually the first year in several decades that they won't be able to get down there and take their measurements. It's a great question, though, Matt.
Or if they do go down there, they'll have to wear face masks.
Actually, a friend of mine was just telling me about the Antarctic Protocol. So it's mostly just engineers and builders, people that are maintaining the station, going down to McMurdo this year. But apparently they fly to California, take COVID tests, stay in an isolated unit. Then they take a charter plane to New Zealand, where they then isolate again for 2 weeks while they take more and more COVID tests, in line with New Zealand policy. And then at some point, barring weather delays, they get to fly to Antarctica, but they're doing everything they can to prevent an outbreak.
One more question. You mentioned your kids. Do you ever think about writing a book for kids on Mars or on your work?
Oh my gosh, wouldn't that be fun? So that actually hasn't crossed my mind. I'm not sure I'd be great at writing a kid's book, though it could be a fun project. But I will say a good friend of mine, Bethany Ellman out at Caltech, has written a marvelous children's book about Mars and exploring Mars and rovers. And it was published by the National Geographic Society. And so I really recommend that one for Christopher and any other kids that are on the call. I think you'd really enjoy it.
Well, we're almost out of time, but I wanted to say, we haven't talked about the actual writing of the book. I mean, we've talked about the content of the book, but it's actually a beautifully written book. And in science, we are taught, we being researchers in science, that content is much more important than style. It's the facts are much more important than the way that you express the facts. But anyone who reads your book, which I highly recommend, is going to enjoy the style, the writing style, the attention that you give to the stories you tell, to the use of language, the way that you put sentences together. So how do you, as a scientist who also writes, is the last question, how do you balance style with content, and why was it important for you to pay attention to the actual quality of the writing in addition to the content?
Well, I mean, that's sort of how the book began, Alan. I'd be engaging a lot with scientific content. I'd be reading papers and going to seminars and lectures, and there would be these things that would strike me as just incredibly evocative or poignant or compelling, the sorts of things that would never find expression on the pages of scientific journals. And I would sort of scribble them in the backs of notebooks, you know, that left out content in a sense that just like didn't make it into the scientific literature. And that's kind of what started it all. Like, and those ideas kind of collated into passages, and those passages became chapters. And I think I just felt that, you know, Mars needed in some sense like a different kind of treatment, you know, something that really captured the wonder and the majesty of the whole endeavor. And I guess that's what I really hope that the book has become or will be seen as by the folks that read it.
Well, it's a very poetically written book, and I think it will appeal not only to people who are interested in Mars, but people who like good reading and like the kind of imaginary journey that we go on when we read something that's really written well. So we've run out of time, and I apologize to the people who have asked questions that we haven't had time to address. And it's been a privilege for me to be able to talk to you, Sarah, about your wonderful new book. And I hope that that people will read it and get to learn not only about Mars, but to get to learn more about you, because there's a lot of your personal story that's in the book. That's one of the things that makes it interesting to read.
Oh, well, thank you, Alan. And there's nobody I'd rather share the stage with. I mean, Alan, you're one of my very, very favorite writers. And thank you so much for taking the time and for everything you've done for me throughout my life. Like, I really, really appreciate it.
Oh, it's been my pleasure. So we end the session now. I know that that Tom at Politics and Prose is probably monitoring this, but I want to thank everybody for tuning in. There you are, Tom. Thank you everyone for tuning in. Politics and Prose, I have to mention, is one of the great bookstores in the Washington, D.C. area. I have been there many times myself, and it's just one of the great independent bookstores in the country.
Well, thank you so much, Alan, and thank you both of you, Sarah and Alan, for a fascinating talk. We have a lot to think about and now, and just a reminder to everyone in the chat, there is a link to the Sirens of Mars. We really encourage everyone to buy a copy, and we'll see you all next time on Politics and Prose Live. Thank you again, Sarah and Alan.
Thank you, everyone. Thank you, Tom.